This is a paper review of the investigation of fracture and surface analysis of joint interface glass metal by Jason He and Jonathan Lerner. Combining two dissimilar materials is considered to be an extremely difficult but attainable task. It is useful in complex structures like you see on the right, where the benefits of more than one material may be needed to achieve your goal. As you can see on the top right, glass and steel was used to create a both beautiful and functional ceiling. The more different the materials are, the more difficult it is to form a proper continuous joint. For example, forming one continuous joint between glass and steel is much more difficult than glass and ceramic, whose properties are much more similar. The more dissimilar they are, even the properties of adhesive have to be taken into account to ensure that they could stick to both of the materials. The experimental part. Borosilicate glass and stainless steel were bonded together with powdered borosilicate glass used to bond the two materials. All the materials were cleaned and the stainless steel is oxidized at a temperature of 600 to 700 degrees Celsius at 1 atmospheric pressure. The powdered glass was wetted more at a higher angle of contact between the two materials, meaning that the angle between the borosilicate glass and the steel was higher, and lower when the angle was smaller, in order to improve the rigidity of the joint of the combined materials. The glass and steel joint was formed at a high pressure and temperature in order to ensure a strong joint.
So now I'm gonna talk about the result of the experiment. The first thing we need to prove is the oxidation of metal surface prior to bonding does increase its bonding strength. The two pictures on the slide shows the comparison between metal surface before and after oxidation. You can see some metal oxide formed on the surface of the metal, which will be proved to enhance the bonding strength of filler gas powder on the alloy. The two mechanisms of bonding glass metal were achieved. The first mechanism was performed by laying all point joint parts into a furnace before pre-oxidizing the metal surface. It was found that the bonding is very weak and is only about 0.1 to 0.2 megapascal for all types of metal tested. The second mechanism of the bonding glass metal is by pre-oxidized metal surface and before putting the metal and glass into the furnace. It ends up the maximum bond strength between the glass tube and the metal sheet is 2 megapascal, which outperform its unoxidized counterpart significantly. So this picture shows new substance forming from the intermediate layer of a powder gas steel due to the interaction between glass and metal components. The opaque region represents the metal part on the left, and the region on the right shows the glass tube. And there's an intermediate layer between them, which consists of oxide growth on the surface of metals, which interact with the glass parts. The intermediate layers consider an important region in the mechanism of a glass metal bonding. Thickness of the adherent oxide growth is classified as an active bonding filler attributed the joint reliably. There are some bubbles present in the intermediate layer performed from the vacuums in filler gas powder, which could potentially lower the strength of the joints. So there are three fracture patterns of the experiments. The first is the breaking from a glass base, which, as you see in the picture, the metal surface and the oxidizing layer, as well as the glass powder layer, is intact. However, the glass base breaks from the metal sheet. The second is from the intermediate layer. As you see, the glass tube and the metal sheet are both fine, but the vacuums in the intermediate layer causes it to fail catastrophically and just make the glass tube detach from the metal surface. The third one is the failures of the oxidized layer of the metal. As you see, the whole layers of oxidized metal just peel off from the metal and expose the pure metals underneath. The conclusion: a good oxidation of the alloy surface can enhance bonding strength of gas metal points. This technique is implemented by carefully select both furnace temperature and holding time. 2. New faces at intermediate layer can enhance the bonding strength of glass metal. 3. The number of bubbles per unit area and its diameter plays an important role in the mechanism of joining glass metal. Thank you very much.